You've seen the fires, the EV battery fires that take forever to extinguish, challenges the fire departments and first responders are beginning to face with the increase of those vehicles on our roadways. Forget the fact that it happens at a lesser rate than even internal combustion engine cars, but you've seen them. Let's deal with the question that we haven't asked. How safe is an EV in a crash? It would please you to know that our federal government, even though they don't have standards on what an autonomous vehicle should do, they do have standards relative to what and how an EV should perform in a crash.
Well, that makes sense, though, Ken. I mean, we've talked about autonomous vehicles. They're technically on the roads, but in very limited capacity.
My problem is, until they specify what minimum is.
I agree. But they're only on the road with pilots right now.
But they're also petitioning the federal government for a larger role and to go private.
Yeah, totally fine with that. But it makes sense they would have EV regulations because EVs are everywhere.
I want a standard. Anyway, we have one. I'm not sure if you're familiar with federal motor vehicle safety standards, but they've been around for years and every vehicle on the road must meet them. In addition to the variety of federal motor vehicle safety standards that internal combustion vehicles must meet, there is one called Federal Motor Vehicle Safety Standard number 305. And I want to explain it to you. The title and this standard is 70 pages long from the U.S. Department of Transportation, National Highway Traffic Safety Administration. And this is the laboratory test procedure for what they need to do to meet or prove Federal Motor Vehicle Safety Standard 305, which is electric-powered vehicles, electrolyte spillage, and electrical shock protection. This standard specifies performance requirements for the limitation of electrolyte spillage, retention of propulsion batteries, and electrical isolation of the chassis from high-voltage system during a crash event. This standard applies to vehicles that use electricity as propulsion power. This is not proposed. This is an actual rule in effect right now. And they didn't stop there. The only question I've got is why they're doing this in European measures, and this is a U.S. safety standard. The standard is applicable to passenger cars, multi-purpose passenger vehicles, trucks, and buses with a gross vehicle weight rating of 4,536 kilograms or less that use more than 48 nominal volts of electricity as propulsion power and whose speed attainable in 1.6 kilometers on a paved level surface is more than 40 kilometers per hour. I just didn't understand why they quoted that in the metric system.
What's the article from?
It's not an article. This is the actual print from the U.S. Department of Transportation. This is not an article. This is actually page 1 of the general requirements, subsection 2. Let me lay this on you, because these are the standards. While tested to the procedures contained therein, and we're not going to talk about all the procedures, each vehicle to which the standard applies shall not spill more than 5 liters of propulsion battery electrolyte outside the passenger compartment, and no visible trace of electrolyte shall spill into the passenger compartment. Spillage is measured from the time the vehicle ceases motion after a crash test impact until 30 minutes thereafter and throughout any static rollover after a crash test impact test. Have any propulsion battery system component located inside the passenger compartment move from the location in which they are installed. Have any propulsion battery system component located outside the passenger compartment enter the passenger compartment. Fail to maintain an electrical isolation of no less than 500 ohms per volt between the propulsion battery system and the vehicle's electricity conducting structure. Vehicles will be tested to the requirements of Federal Motor Vehicle Safety Standard 305 and perform applicable crash tests. The governing crash tests are utilized when testing to other dynamic standards. The vehicle must also be able to meet the requirements of any of the governing crash tests. What that means is, in addition to this, it must meet all the other tests that internal combustion engine vehicles are currently subjected to. All of them. Low speed tests, side impact tests, all those. So, having said that, to reiterate, one of the key requirements for 305 is energy storage. So the energy storage device during after impact for the crash test has to be isolated. This is the thing. Bear in mind, these batteries in the type of architecture that automakers have largely adopted called a skateboard. The batteries are basically forming the floor of the car or the floor of the SUV or truck. That's where your batteries are. So they work very hard to make sure that that is not compromising any kind of a test. So bear in mind, it's not in the front of the car, it's not in the back of the car, it's basically underneath you. So other than side impact, chances are these are going to be fine. But let me throw this at you. Solid state electrical EV batteries, no electrolyte, no fluid, because the solid state is dry. This is where the automakers are going, and this would have superior performance and advantages in 305 because it wouldn't spill. It wouldn't short out. There's no chance of having those kinds of problems for which that standard says. So I guess to reiterate, electric vehicles are safer because there are additional standards above the regular federal motor vehicle safety standards that they must meet. And that standard is number 305. That's the additional standard. So EVs are not being subject to less regulation, if anything more, and it's measurable. They are very specific about what this vehicle needs to do in case of an accident and how it needs to perform in the case that you're driving or you're in a vehicle that's an EV and it's in an accident. You know what it's designed to do, and it had to meet those standards. There's no way around it. Pure and simple. It's the one thing I wanted to share, and the proposal, they also are talking about, they wanted to extend 305 to heavy vehicles too, because we're talking about medium duty vehicles that will have batteries. They want to extend that to that too. It doesn't apply to heavy vehicles yet, but they're looking to extend 305 to meet those standards as well. And it also includes requirements to mitigate battery fires during normal vehicle operations, including exposure to water while charging and after a crash. They're not playing. And they monitor battery temperature when they test these things in a crash, because a thermal runaway is an issue that could cause a fire and other harm. And it's not supposed to do that. So, short answer, yes, they're safe. As long as they meet this standard. And they're being tested to meet the standard. And they can't be sold unless they do.